Hello there, children. Today, we are going to work on the section 3.1 to 3.2 review. Alright, so problem 1 is another one of those fancy word problems. So as you read through that, I've got some things to figure out. I need to make some equations. So in doing that, I'm going to look at the data that I am given. So, we look at this data here. And I pull out some information. Okay. Ashley spent $102 on 8 daylilies and 3 pots of ivy. Well, what is a cost of a pot of ivy and a daylily? I don't know. I'm going to use a key, D for daylilies again. Now, again, we talk about in class, you want to definitely make sure that you use something that makes sense. You can use X and Y. I would not use, like, D for pots of ivy, though. And P for pots of ivy. Here. I wouldn't reverse them because that's a recipe for disaster. So, based on Ashley here, 102 equals 8D plus 3P. Alright, I need another equation. And reading through the problem, luckily, good old Dan the man here, Dan spent $100 on 7 daylilies and 8 pots of ivy. Alright, so that's 100 equals 7D plus 8P. Alright. So, looking at this, I need to figure out what to multiply these equations by. Well, I've got the option of making the D's look the same or the P's look the same. I'm going to go with the P option here. Multiply the top equation by an 8. Bottom equation by a -3. Now, you might ask, well, why, Mr. Faust, are you multiplying by a wonderful and glorious negative there? And that's an excellent question, because I would prefer, if I can avoid it, not having to subtract these things, because I know that's a recipe for me messing it up. Negative 21D minus excuse me, 24P, that equals -300. Now, when I do this, I'm going to get the following. I get -516. This gets me a 43D. These things cancel. Then I divide 516 by a 43. Sorry, positive 516, not a negative. And then I get D equaling 12. Now, that's an excellent point. I just put a negative there by accident. Kind of on purpose. If you get a negative here, you know it makes no sense because these are real world problems. So, when I do this, I go through here, put D into one of the equations. I'm going to put it in the top equation because I can. And all shall rejoice. Now, you do 8 times 12. You use your magic sheet of letters if you need it. That's 96 plus 3P equals 102. You subtract 102 and 96, you get 6. Equals 3P. P equals 2. Now the problem is here, you can't just circle and be done with this. You have to put the dollar symbol in here, or you go back to your key and actually write out a little statement such as this. You must have the dollar symbol or it will not get you full credit. Circle or box in your answers. Next problem. This is the next problem. I have taken the time to already write out the equations to save you time of watching me actually do this. And if you look, Jacob sold 14 bags of wildflower. I made wildflower W and crocus C, which seems to make the most sense to me. Now, when I do this, I want to make the C's look alike. You can clearly see here, oh, wait a minute. If I multiply this one by a -2, I've got what I need, which would be glorious. So the top equation doesn't change whatsoever. The bottom equation, however, will change. Multiplying by a -2. Now let's figure this out here. When I do this, that's going to get me -320. Now, you've got to realize something here. I know what you're thinking. If you do the right side here, you get -6W. The 12s cancel, and you're like, oh no, I've got a negative. Whatever shall I do? Well, you've got to remember to look at the other side first before we start to panic. And lo and behold, I get negative 42 over here. And when I divide negative 42 by negative 6, I get W equaling 7, which is fantastical. So, I've got W equaling 7. What do I do with that? I'm going to jam it into one of the original functions. I'm going to pick the bottom one this time. So I go ahead and do that. Now, when you go about doing this, you have to remember that doing this information as such, it's a 6 there, sorry, you get a 90 equals 6C, and C here, your crocus bulbs will equal 15. So you put that up here in our chart, you go either or down here. Either you do dollar symbols down here and circle, or you put it up here. Great rejoicing shall be had by all. Huzzah! Alright, moving on. The next problem here is a bit of an issue because, as you can clearly see right now, neither of them are in standard form or slope-intercept form, which makes everyone particularly sad. Womp womp. However, what I can do is I can transform each equation into standard form. All I'm doing to the one that I have highlighted in green there is I'm adding 3 to both sides and then dividing by a negative 1. Now, when I do that, I go down here. Then I go, oh, the slope's positive now, up 7. 1, 2, 3, 4, 5, 6, 7, over 1. And connect your graph with a line. Okay. The bottom equation, also not in standard, or see the bottom, the top equation that's highlighted in red here, also not in standard form. So what I'm going to do, or slope-intercept, I'm going to add 3 to both sides. And then, I'm going to add x to both sides. Now people are like, wait, it's not y equals mx plus b. It actually is. Watch, I'm just going to flip it around. Put the x first. All I did was read this backwards, folks. Alright, have a positive 3 here. Go up 1 over 1, because that's my slope, or down 1 to the left 1, if you so feel the need to do so. Now, the question is, what's my solution here? I've got one solution, and it's right there. So my one solution, and luckily for us, it happens at a coordinate that I can graph and look at. And it's a coordinate that's a whole number. There's my solution. It's one solution, and it's where they intersect. Huzzah! Now this next problem here, I have taken the liberty of already solving here for my variables, which is wonderful and glorious. I put it into y equals mx plus b form because I think it would be the most beneficial for us. So I go ahead and go through this. Now I can graph. Alright, the x equaling negative 3 always tends to bother people. Remember, that's a vertical line at x equals negative 3. Sound effects optional there. Now this other line, y equals x plus 2, I go to the 2 here. And I go down and to the left or up and to the right to get my next line. And as you can clearly see here, I have one solution. It's where they cross. That is at the point negative 3, negative 1. All right, moving on here. Okay, solve these systems. Now remember, on the quiz, I am not going to tell you how to solve them. This is teed up for elimination, though, simply because I don't have anything here that has a 1 or negative 1 in front of it. But I know if I multiply the bottom equation by a 4, let's put this in the center so we can see it a little better. If I put this bottom equation by a 4 here, then I know I've got negative 8x and 20y. That equals negative 28. Why in the world would I do that and leave the top equation alone? Look at my x's now. They differ only in sign, so what I can do is add them together. 8x plus a negative 8x, x's go away. 6y plus a 20y, 26y. 2 plus a negative 28 is negative 26. Divide by a 26, I get y equaling negative 1. What do I do with this y equaling -1? You can put that into either original equation. I'm going to pick the top one this time. Does it really matter? Absolutely not. Very good imaginary voice in my head. It does not matter where you put it, so that's wonderful and glorious. But luckily here, I can put the -1 in for x, and when I do this, I get 8x minus 6 equals 2. 8x Now, how could I check this? How could I check this answer? You've got two options. You just go, I'm not going to check it, not smart. Or you put x equaling 1, y equaling -1 into each of those equations. Remember, if it's a good solution, it will work for both equations. It has to. Circular box in your answers, or if you were feeling so particularly fancy, you could write it as a Cartesian coordinate, as such. Okay. Moving on. We have this particular problem here. I'm going to multiply the top equation by a 2. When I do this, some people want to know, why am I doing this? Well, again, it's all about those x's. And I look here, and I made them the same. Now, truth be told, you could make the y's look the same, but why would you want to do that here? There's an 8 and a -7. That would be somewhat difficult. If I multiply the top equation by a number, I can get this done just as easy. So I get 9y equaling 9. That's going to be y equals 1 this time. All right, I'll put it into the bottom equation because I put it in the top one last time. So y equaling 1. Now, the only trick about y equaling 1 here is you do want to keep track of your negative signs, gang. So it's -7 equals 9. That's 8x equals 16. That means x equals 2. You can circular box in your answers as such, or write it as a Cartesian coordinate plane number, such as that. So moving on to the next problem. Okay, this problem now. This problem poses me somewhat more difficulties than the other one has, because if you look, well, now I just can't multiply one equation and get the job done. I've got to multiply by 2 equations here. So you either make the x's look the same, or the y's look the same. It doesn't particularly matter in this case. Now, since I made the x's look the same in the last 2 problems, I'm going to go after the y's here. So I'm going to make them both be 14s. That means multiply the top equation by a 7, bottom equation by a 2. Now, you have to remember here that when you do these type of problems, you definitely want to share and care. And what does that mean? Remember, you want to share that 7 with every single item. You want to share that 2 on the bottom with every single item. Missing that will cause you disaster in a problem. Absolute disaster and destruction. You won't get the correct answer. Now, we're going to add these up. I get -22x, 14y plus a -14y is 0. It's exactly what I wanted. -42 plus 42y is 0. Oh no! Oh no! But remember, I still have a variable here. Divide by -22, I get x equaling 0. That's totally okay, folks. When the variable goes away, both of them, then I've got problems. But I still have a variable here, so it's okay for a variable to be 0. So I'll put it in the top equation this time. 6 times 0 plus 2y equals -6. I get 2y equaling -6. It's y equaling -3. Oh, happy days are here again. Circle your answers or write it as a coordinate point. Let's keep on trucking, shall we? Okay, number 8 here. Quite the interesting problem. Again, I've got choices here. Now, I'm going to pick the x's here only because, look, one's a 10x and one's a -6x. One's positive, one's negative. That means all I have to do is make them look the same. I don't have to introduce a negative. If I try to make the y's look the same, that would mean I would have to introduce a negative there, and if I can avoid doing that, I'm going to. Now, this is where you have those magic cheatalators of yours to help you out with all this fun stuff. As I slowly just work my way through here, through this problem, multiplying stuff out. You have a calculator, so I definitely suggest, if you need it, relying on it, because some of these numbers are quite difficult to try to multiply. So you've really got to look at those. Now, I'm not saying any of these should be difficult. And poof, calculator magic. Now, when I go through these, 60x plus a -60x, nothing. Negative 54y plus a negative 80y is negative 134y. Oh boy. Negative 114 plus a negative 20. Oh, negative 134. I'll get y equaling 1. Oh, happy day. And now going through and shoving that into, let's go the bottom equation this time. Negative 6x minus 8 times 1 equals negative 2. Now, the reason I'm putting it into the original, gang, is I know that's right. You want to be careful about putting this into the top equation that you created right here. In case you accidentally multiply it on, you're really going to be in for a rough go of it. So that's my personal suggestion. Go back to the originals. You know the originals are always right. And when you get these done, don't just sit on your laurels and go, yay, I'm done, oh, happy day, here again. You need to go ahead and check these answers in both equations and make sure they work. Moving on. Okay, now when I do this problem, number 9 here, this is tailor-made for substitution. Why? I've already got an equation solved for x. So all I'm going to do here is I'm going to take, solve for y, excuse me. It's got an x in it. I'm going to take and replace that y in my second equation with the y I found in the first equation. What is that going to look like? I'll get 15x minus 3. And I replace it now with this. Now, why do I do that? Because now I've got one equation, so what? But I've got one variable. Alright, 15x minus 15x, 0? 0 minus 6, uh-oh, uh-oh, uh-oh. Remember, both my variables are gone now. That should set off panic alarms. Is negative 6 equaling 0? Last time I checked, it's not. Sad face emoji. No solution here. Now, remember, this works because I have something not equal to itself. If I had 0 equals 0 or 7 equals 7, that would, remember, be infinitely many. In this case, I've got no solution. It means if you were to actually graph those lines are parallel to one another. Okay. This equation, super easy. When you do this equation, simply put, you're going to put negative 3 in for the top. How do I know that so quickly? Well, the bottom equation is y equals negative 3. That's pretty simple. So all I'm going to do in the top equation is put negative 3 in. I'm not saying you'll get an equation that easy, but if you do, say thank you, sir, and substitute it in there. Now, I just solve here. Now I get 8x, add 18 over, you get 16. X equals 2. Now, what did y equal again? Well, luckily they told you in the problem what y equals, so you better put that in your answer. Y equals negative 3. And you can substitute both these into the top equation to make sure they work. And now, last but certainly not least, this one you can do either way. I'm going to do elimination here. Now, you know what? We'll do substitution. Why not? Because that's a y equaling coefficient of 1. So all I'm going to do there is I'm going to add 8x over. And I'm going to put this in everywhere I see a y in the top equation. So what does that look like for us? Well, I have 3x minus 8. Now, here's where it gets a little tricky. Notice how it's a negative 8 on front. So I've got to put this in here. So let's go ahead and work on this. I get 3x minus 64x minus here 24 equals negative 24. I get negative 61x minus 24 equals negative 24. I add 24, I get negative 61. X equals 0. That's okay. We're fine. X could be 0. And what do I do with that? I'm going to put that in an equation. Now here, look, if only I had an equation that was solved for y already. Oh, wait. I've got one sitting over here. So go y equals 8 times 0 plus 3. Y equals 3. There you go. Circular box in your answers. Or write it as a coordinate pair. You are now ready for your quiz. Oh, happy days are here again. Go henceforth and do.